Nathaniel Bugle, and I will be talking to you about electric current in this short presentation. I would first like to define what electric current is. Electric current is defined as the flow of electric charge in a circuit, normally from an area of positive charge to an area of negative charge. As you can see in this equation, current, represented by the letter I, is calculated by how much the charge moves in a given amount of time. Current is measured in amperes, or coulombs per second. Now there are two main types of electric current: alternating current and direct current. In an alternating current, the current periodically changes from a positive to a negative direction. Alternating currents have the ability to produce various different waveforms. The most common waveform for an AC current is an oscillating wave. The diagram below depicts the relationship between current and time. As you can see, the direction of the current goes from a positive direction to a negative direction and back again. On the other hand, in a direct current, the current is not affected by the time. The flow of a DC current travels only in one direction and one direction only, either positive or negative. In DC currents, a constant voltage is produced over time because the direction is constant. A great example of this type of current is a battery. I would now like to share a scene from one of my favorite childhood movies, Iron Giant. As you can see, the giant, being made of iron, which is one of the top 15 most conductive metals on Earth, simply touched the power lines of the power plant, and the current immediately flowed into him. Power plants naturally produce alternating current, but also have the ability to transform that current into a DC current. This example is great because it shows how the equation to calculate current actually works. In this scene, there is a massive charge that moved in a split second, showing that there is a large quantity of current flowing in the giant. In conclusion, I defined the electric current to be the flow of electricity in a circuit. I provided an equation to calculate the amount of current by taking the amount of charge being moved in a given amount of time. I also compared the two types of currents: alternating currents and direct currents. After watching this presentation on electric currents, I hope you all found them to be interesting, and I hope that you learned a lot. Thanks for listening.